Everybody, come let's go with computer control of power system. In this PowerPoint presentation, it contains so many contents. All those contents are listed here. Following that contents, we have to see need of computer control. Uh, the need of computer control always depends. Electric power system have grown in size of complexity, so it becomes essential to monitor their operation simultaneously with automated control system. Energy management is the process of monitoring, coordinating and controlling the generation, transmission and distribution of electrical energy. Let's go with the black diagram of this energy control center. The process of monitoring, coordinating and controlling the power system is performed at control center known as energy control center. I told the previous slide. Among those explanation is very essential for this computer control energy. So let us see, the energy control center has traditionally been the decision center for the electric transmission and generation interconnected system. The energy control center provides the function necessary for monitoring and coordinating the minute by minute physical and economic operation of the power system. In the continental US, there are only 3 interconnector regions: Eastern, Western, Texas. But there are many control areas, with each control area having its own energy control center. Maintaining integrity and economy of an interconnected power system requires significant coordinated decision making. So one of the primary function of the energy control center is to monitor and regulate the physical operation of the interconnector grid. Most areas today have a two-level hierarchy of energy control centers with the independent system operator, that's called ISO, performing the high-level decision making, and the transmission owner energy control center performing the lower level decision making. At the same time, the higher level view of the energy control center is illustrated, where we can identify the substation, the remote terminal unit, that's called RTU, a communication link, and the ECC, which contains the energy management system. The energy management system provides the capability of converting the data received from the substation to the types of screens observed. In this notes, we will introduce the basic component and functionality of the energy control center, that there is which provide is this information. Then we have to look at energy control center. This is black diagram of energy control center. The system control function traditionally used in electric utility operation consists of 3 main integrated subsystems: the energy management system, the supervisory control and data acquisition, that is called SCADA, and the communication interconnecting EMS and the SCADA. All those things are noted down on this black diagram. This black diagram provides illustration of these 3 integrated subsystems. The SCADA and the communication subsystems are indicated in the dotted ovals at the top left hand corner of the figure. The rest of the figure indicates the energy management system, that's called EMS. We will describe each one in the following subsections. Distinguish EMS from distribution management system. Both utilize their own SCADA but for different functions. Whereas EMS SCADA serves the high voltage bulk transmission system from the ECC. The DMS SCADA serve the low voltage distribution system from the distribution dispatch center. We are addressing in these notes this EMS and SCADA. It has operation and control center that will be monitoring data acquisition and remote control. It has some levels to control their energy center. That's our turbine governor adjusted generation to balance changing load instantaneous control. Second one is AGC called load frequency control. We had been seen third note of this power system operation control. So AGC maintains frequency and net power interchange. Economic dispatch control distribute the load among the units such as fuel cost is minimum. Does primary voltage control, that control or excitation control, transmission voltage control, SVC, shunt capacitor, transformer taps. This is explanation about this black diagram. Come, let's go with energy control center. This explanation also explained the previous slide. Next, data acquisition and control. It means this two code inbuilt of SCADA. SCADA explanation is expansion of SCADA is supervisory control and data acquisition system. That word can give a data acquisition and control. There are two parts of the term SCADA. Supervisory control indicates that the operator residing in the energy control center ECC has the ability to control remote equipment. Data acquisition indicates that information is gathered characteristic on the status of the remote equipment and sent to the ECC for monitoring purpose. The monitoring equipment is normally located in the substation and is consolidated in what is known as the remote terminal unit RTU. Generally, the RTU are equipped with microprocessor having memory and logic capability. Older RTUs are equipped with modems to provide the communication link back to the energy control center. Whereas newer RTUs generally have internet to internet capability. Relays located within the RTU and command from the ECC open or close selected control circuit to perform a supervisory action. Such action may include, for example, opening and closing of the circuit breaker, then the system having the relays located within the RTU and command from the ECC open or close to selected control circuit to perform a supervisory action. Such action may include, for example, opening or closing of a circuit breaker or which modifying a transformer tap setting, raising or lowering a generator megawatt output or terminal voltage. Information gathered by the RTU and communicated to the ECC includes both analog information and status indicator. Analog information includes, for example, frequency, voltage, current, and reactive power flows. Status indicators include alarm signals and whether switches and circuit breaker are open or closed. Such information is provided to the ECC through a periodic scan of all RTUs. A 2-second scan cycle is typical. Then, function of a SCADA system. It contains 12 functions: data acquisition, information display, supervisory control, that means on and off, generator stop and start, rise or lower commands. Fourth one is information storage and result display. Fifth, sequence of events acquisition. Remote terminal unit processing, general maintenance, runtime status verification, economic modeling, remote start stop, load matching based on economics load shedding. The structure of SCADA system always having the explanation of above slide. It contains auxiliary memory, computer programming input and output equipment, communication interface, CRT display, control console, RTUs, different kind of RTUs. This is functions. This is remote terminal unit. Remote terminal unit can say with the respect of supervisory control and data acquisition system responding their level of process controlling unit. This is a remote terminal unit. This remote terminal unit always having some except concept of exponential, that mean various remote terminal units or special purpose current and computers which contains analog to digital converter, digital to analog converter, digital inputs and outputs. The inputs and outputs are fully protected against superior electrical transient. RTS or RTUs may be either AC powered, that AC power contain 120 to 230 volt, or battery powered 12 volt, 24 volt, 48 volt, 125 volt or 250 volt. This is challenges of SCADA. SCADA always challenge some of exposure of system control. That challenges are ensuring availability of correct data and total observability of the power system in real time, ensure foolproof safe system functionality on 24/7 basis, implementation of innovative techniques to ensure situational awareness for the grid operator, utilization of almost EMS function to anticipate and analysis grid incidents. A growing network complexity need increased automation in grid power system. Thank you.